Just did more. Just came as I know.
Good job, I win. I win. It's awesome. Awesome. Awesome sauce.
Oh my gosh.
I'm not even saying awesome anymore. I'm just gonna say like a combination of applesauce and awesome. I know awesome sauce.
No, did you get that from that old commercial?
I like berries.
The Discover FICO and credit card.
No, I don't even know what that is.
Oh,
It's like when
Joe Mountain.
calls Annabelle.
Okay, is it on here?
Oh, they're like, no. She's a white queen. She's like,
Alright, go ahead and get out your homework, please.
I feel like I knew that.
she was calling me that.
Where is it? Moody Bible College? How did it go?
This makes so much sense, like, I love this chapter.
Oh, yeah, yeah.
Oh, it's only one section so far.
I'm
but-
loving it.
Well, good.
Festival,
I like your, what, do you call that a scarf?
Yeah.
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 I didn't know because it was so sheer, like, I like it anyways.
I did wonder about 16, I got a decimal.
Okay.
Not good at that.
Well, you should have written it as a radical in simplest radical form.
Can I go get some about those flowers in the.
I feel like all the other chapters, I wanted to cry because they're so good. And this one I want to cry because it's like awesome and I understand it.
I did understand it.
I'm not sure if that's a good thing or a bad thing. Oh my gosh. We have to do theorem 7.2 to 7. Oh, this is not on the same chapter, just kidding. Whoa. I was like,
That's a lot of notes.
oh. But we have,
Alright. You can see that?
yeah.
Sometimes it. Number 16, x squared equals 63. So you would take the square root of both sides. So really you just have to simplify the square root of 63. 63 would be 9 times 7. Or 3 times 7, which, so therefore that would be 3 root 7. I mean, if you type it in your calculator, yes, you're gonna get a decimal.
That's what I did.
But,
I did that.
okay, good, yes. Because you're supposed to leave it in simplest radical form.
I was like, what?
I'm glad you're so excited about this.
You're just like, oh, yes.
Yes. Alright, were there any other questions? No? Okay. Then we're gonna start with the Pythagorean theorem. I'm sure you've heard of the Pythagorean theorem before. In our book, it's theorem 7.2. Which says that in any right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs. And you've all heard it as what? A squared plus B squared. Oop, whoa. A squared plus B squared equals C squared. Where C is the hypotenuse and A and B are the legs. And so that's what that would be written out in words for theorem 7.2. So just remember, it doesn't matter which leg you say is A and which leg you say is B, the legs are interchangeable. but it's very important that you know which side is the hypotenuse. And how do you figure out which side is the hypotenuse? It's across from the right angle, right. Theorem 7.3 is the converse of the Pythagorean theorem. What does converse mean?
Reverse.
Right.
Or
So, so basically, if the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So this one's saying if it's a right triangle, then this is true. So the converse would be if a squared plus b squared equals c squared, then it's a right triangle. And you don't know necessarily which side is the hypotenuse because you don't have a right angle that's labeled for you, but the hypotenuse would be the longest side.
Do we have a workout test today?
So this is saying if a squared plus b squared equals c squared, where c is the longest side, then it's a right triangle. So it's the converse where the if and the then statements are reversed. And when you're finished with that, if you would get out your book and turn to page 239. Okay, so let's look at the oral exercises. And exercise 1 through 6, and I'm gonna write the answers down, but you don't necessarily have to as long as you're following along. State an equation that can be used to find the length x in each of the right triangles shown. So number 1. Next.
4 squared plus 5 squared equals c squared.
I think it's an x, but
Oh yeah, sorry.
good. 4 squared plus 5 squared equals x squared. Number 2. Wolfie?
3 squared plus 4 squared equals x squared.
Good. Number 3. Hannah?
8 squared minus 6 squared equals x squared.
Okay, and that is true, but I would just go ahead and say x squared plus 6 squared equals 8 squared. And then yes, of course, when you go to solve for x squared, or x ultimately, you would subtract the 6 squared. But we can go ahead and leave it like that for now. Number 4. Sarah?
5 squared plus 9 squared equals, 5 squared plus x squared equals 9.
Good. And 5. Madeline?
3 squared plus 7 squared equals x squared.
Good. And 6. Morgan?
5 squared plus x squared equals 10 squared.
Good. Okay, so that should be pretty familiar to you guys, I'm sure. In exercises 7 through 12, the lengths of 3 sides of a triangle are given. State whether the triangle is a right triangle. So, how are we going to do that? Okay.
For like numbers, I don't take the two smaller numbers and you add them squared and it equals the
Good. So we take the 2 smaller numbers squared, so 2 squared plus 3 squared, and we're trying to see, does that equal 4 squared? So what's 2 squared?
4.
3 squared,
9.
and 4 squared?
16.
Does 4 plus 9 equal 16? No. So that's, no. So 8, we would do what? Yeah?
3 squared plus 4 squared equals 5 squared. And then, 3 squared obviously is 9, and 4 equals 16, and 9 plus 16. What? Oh, equals 25, so that's right.
So yes. Good. 9. How would we check that? Madeline?
You do 3 squared plus 3 squared equals 4 squared, which is 9 plus 9 equals 16. And that's no.
9 plus 9 does not equal 16. Nope. Good. 10. Max?
3 squared plus 5 squared equals 6 squared. So 16 plus 25 equals 300.
No. Does not. 11. Okay.
6 squared plus 8 squared equals 10 squared, and that would be yes. Or it'd be 36 plus 63 equals,
64.
oh, 64. Oh, that would be no then. Alright. No. It would work. Sorry.
You are right about the
I was
yes.
thinking right.
Yes, it does work. So that would be yes.
My bad.
And 12. Sarah?
2 squared plus 2 squared equals the square root of 8. And
Square root of 8
squared.
squared. Good.
And that'd be 4 plus 4 equals 8, which is
Good. Do you see that if we take the square root of 8 and then we square it, the square root and the square undo each other, and that just leaves us with 8? Yes? Okay. Alright, we're not going to look at 13 through 18. So, your assignment. Anything else? Oh, I wanted to do a couple examples with you. Oh yeah, I wrote them down. I forget that I do them. let's do a couple examples from your assignment. So number 4, they've given you this triangle and they tell you that BC equals 5 and AB equals 6, and they want you to find AC. So I would recommend drawing the triangle for those, because otherwise it's hard to remember what the hypotenuse is, or you could just look at it and see that the hypotenuse is AB, so for all of those measurements that they give you, if it's AB, that one's gonna be the hypotenuse. But how would we solve that for x? Wolfie?
So, would it just be 6 squared minus 5 squared equals x squared?
Yes, and I'm gonna go ahead and write it this way: x squared plus 5 squared equals 6 squared first, and then, yes, you would subtract the 5 squared from both sides. So you'll have x squared equals, and what is 6 squared?
11,
36, and 5 squared is,
25, so it'd be 11.
okay? And so then how would you find x?
Square root
3
of
squared. So x will equal the square root of 11. I want you to leave your answers in simplest radical form, or simplified radical form, and since 11 is prime, that's in simplest form. But if it can be simplified, you need to simplify it. Okay, and then 24 in that section, it says find the lengths of two sides, or no, it says the lengths of two sides of a right triangle are given. Find 2 possible values for the length of the third side. Okay, so how could there be 2 possible values for the length of the third side? Matt?
You could have a hypotenuse, and then the hypotenuse would be the higher number of these two numbers, so you could have split just like
Okay, good. Right. The third side could either be the hypotenuse, the longest side, or the third side could be another leg. So what would be one equation that we would need to solve to find one possible third side? Madeline?
You could do 4 squared plus 5 squared equals x squared.
Okay, good. And in that case, it would be the hypotenuse. And so this would give us what? 16 plus 25 equals x squared. And so 41 equals x squared, so x will equal the square root of 41. And that is also prime. So that is one possibility. And what would be the other possibility, Sarah?
4 squared plus x squared equals 7.
Good. And so we would subtract 4 squared on both sides. So x squared equals 25 minus 16.
No.
9. So x will equal
3.
Since we're solving square root problems, let me just say, normally when you take the square root of a number, you have 2 answers, the positive answer and the negative answer, because if a number is squared, positive 3 squared would equal 9, but also negative 3 squared would equal 9. But since this is geometry class and we're talking about sides of triangles, they're not going to be negative numbers, okay? But just throwing that out there, since we're solving radical expressions and equations, normally whenever you take the square root of something, you have to consider the positive and the negative square root. But since we're talking about lengths and distances, they're not going to be negative, so we don't have to. Okay, any questions? Alright, so your assignment is page 240, numbers 1 through 30 odd. 29. Let me know if you have any questions.
Or can I say something else with those? Like study for an independent study test coming up?
That's fine.
Or if I just go through this now, please. I just go through this now, it's just nice. And are we doing the Far East?
So for like number 9, it's 3 and the square root of 3, how would you do that?
Just what?
It's like 3 and the square root of 3, so would it just become 9?
When you square it, yes. No, it would become like the 3 squared would be 9, and then the square root of 3 would be 3.
Yes,
so it'd be
27.
27.
Oh,
Which country?
this would be 36. So we just did this one on the phone actually. This would be 36 and this would be 64.
Yeah, what are you supposed to subtract from that?
Yeah.
That's
Wait.
What's
Is
this?
it there? That's not it.
No, you'd add these because they're not along the side. You'd add these to find this. So you.
So when you get past 64 and 36?
What's 14 squared?
14 squared? Isn't that
Oh,
the
you're
same?
right, it's not along the side.
What is 14 times 14?
Second. Oh, I did this one. 196.
Okay, I see what you're saying. They're not on the side, I get it. Thanks.
5 squared equals 12 squared equals, and you have to determine if the answers are questionable to those two.
But how would you, how is that proving the answer?
Because this is like, 5 squared is like 8 squared, and 12 squared is like, yeah, and then 13, you have to determine if it's the hypotenuse with the lengths.
I got 10.
66.
Oh, right there, there's the.
Which is 11 minus,
There's the right, you get 2.
So what did we put? True? Or? Okay.
This is walking.
Mhm.
So for number 9, would 3 to the radical of 3, would you square that whole thing or would you just square the
Yes.
radical?
All of it.
All of it?
This one's what we reduced.
169.
I think that's an even one. Check to make sure it's an
Yeah, 'cause I don't.
because I did that. I think it might be number 2 or number 4.
This one I took.
You're supposed to do 3.
Oh, 3.
It's one,
Yeah.
it's the off.
You- this could be ours.
Six 676.
So,
Okay, did the wrong one.
that's 13 times 13. It's in the middle.